Hello, my name is Aurel von Richthofen, and I'm presenting on behalf of the team. My colleagues are Dr. Pieter Herthogs and Professor Markus Kraft. The topic of our panel presentation is addressing challenges of urban policymaking and city planning with the city's knowledge graph. The presentation outline is roughly as this. I'm going to speak about urban policy and city planning and how they rely on data for decision-making. I will introduce Semantic Web Technologies and how they can address challenges in digital urban policymaking and city planning. I will demonstrate the city's knowledge graph and how it supports synthesis processes for future urban policymaking and city planning. Urban policy aims to develop a course of action for the organization of urban systems. In a very simplified sketch, we can think about cities in the present. We can envision a vision for the future in the form of master planning, but this could come in possible future alternatives. And now we need to have a system that tells us how to make decisions to reach an optimal state. This process involves reviewing the state of development at various scales, for instance, territorial, regional, metropolitan reviews, and developing relevant policy themes such as resilience, inequality, sustainability, livability, aging, green growth, climate change, and enabling dialogue within policy networks, for instance, between ministers, mayors, civic society, and industries. For illustrative purposes, we decided to show the UN Sustainable Development Goals or the OECD principles on urban policies. Note that there's always an attempt to showcase the different scales, strategies, and stakeholders, as well as the teams, in a succinct manner. The question is how to derive policy standards, principles, and targets, and should they be blanketed for regions, nations, or should they be tailored to specific needs? And if so, how can we do this driven by data? Urban policy leads to governance instruments in the form of policy standards, principles, and targets. And they need to be adopted and implemented as well. Just like urban policy making, city planning relies on data as well. We see a growing flow of information and requiring actions such as gathering site information, requesting data from various instances or specialists, retrieving past proposals or decisions, documenting processes and methods, building data repositories, or communicating with stakeholders. A major challenge is the discovery, preparation, interpretation, and delivery of data. This applies to city planning as well as urban policy making. This challenge is there despite growing efforts in digitalization through smart cities approaches, digital twins, or even city information modeling. Current policy data systems are restrictive and slow. For instance, on the left, we see the OECD's Metropolitan Explorer platform that allows to browse through key indicators for 649 EOCD metropolitan areas. The platform developed in Singapore by our colleagues called URscape allows to bring together open data so that decision makers in emerging economies can look for optimal solutions under circumstances that cannot directly be determined. These and other systems currently only represent data and have little capacities to synthesize knowledge. The operation of these systems require expert knowledge and excludes large stakeholder groups from participating in urban policy development. Here's where we want to introduce the Semantic Web Technologies as a suitable candidate technology to synthesize processes in city planning and information-driven urban planning. The term semantic web technology and the concept was developed by Tim Berners-Lee, who also invented the World Wide Web. He had the vision to link data and to represent the links or the relationships semantically. The semantic web builds on the availability of, the accessibility of, and the relationship among data. Here we see a visualization of linked data on Wikipedia, and you can see that multiple knowledge domains can be linked in various aspects. Semantic web technology is already transforming the architectural, engineering, and construction industries, and knowledge graphs, which are a form of semantic web technologies, have been developed to plan complex industrial estates. Semantic web technologies promise to overcome current challenges in digitalizing city planning, namely the problem of interoperability of data and machine readability of data, the problem of scalability in the face of large and complex systems such as cities, and the possibility to represent any desirable aspect of the city. We aim to create a city's knowledge graph based on the idea of a dynamic knowledge graph where agents can reconfigure the knowledge graph structure based in changing context and availability of data. We want to do so by automating particular aspects of data gathering and processing and generating useful information and knowledge about cities. By integrating tools, concepts, and targets from different city planning departments based on distinct knowledge domains to make more rounded planning questions. By supporting the creation of specific and of specifications of new urban systems and their parts based on envisioned or desired future urban systems or properties. We focus on the aspect of knowledge management in this presentation, both for city planning and urban policymaking. We show how we can link 3D urban data forming ontologies that we call OntoCityGML based on the open 3D urban data standard CityGML. We perform queries that allow to infer knowledge about the system, thereby demonstrating the potential of our city's knowledge graph for knowledge management. We extrapolate how city's knowledge graph can be used to review development states at various scales, formulate relevant policy themes, and enable dialogue with policy stakeholders. Let's discuss the city's knowledge graph concept step by step with examples. First, we need to develop the data architecture for city's knowledge graph. This work has been published recently in an article on the left, demonstrating our first CKG architecture. The architecture allows us to load city data into a graph database or a knowledge base, in this case, using the platform Blaze Graph. In a knowledge graph, all data needs to be represented as semantically related concepts or ontologies. The backbone of the city's knowledge graph is an ontology in the city's knowledge graph, city's GML format used for 3D city objects. This image shows a bubble diagram of all concepts in our OntoCityGML ontology and their semantical relationship. It is semantically rich, which means it's highly interconnected. Now we want to load multi-domain city data. Data that is available publicly in Singapore includes, for instance, land ownership and land parcels, land use regulations, plots, zones, and gross plot ratio, urban form in the form of so-called level of detail 1 building volumes, mobility data in the form of mass rapid transit stations and bus stops, but also intangible cultural heritage, such as hawker centers. We now want to answer multi-domain urban questions. Simple queries include: what are the land uses within 400 meters of each metro station? What are the 10 tallest buildings in the central business district? What is the closest bus stop of each hawker center? More complex queries include queries that build on sequences of simpler queries. For instance, which land parcel in downtown Singapore have unbuilt gross floor area and how much? How many public transport stops and hawker centers are within 400 meters of each of these land parcels? Because all the main data is interconnected, it can always be included when asking questions or building applications. It is just as easy to integrate something related, for example, to a hawker center, when building questions or applications about mobility, solar energy potential, neighborhood, park accessibility, etc. Because all knowledge graph is always linked to the main knowledge graph already in the city's knowledge graph. Incrementally, it becomes a web of urban knowledge and a very straightforward way to build transdisciplinary applications to inform planning and policy. Let's focus on an example belonging both to urban policy and urban planning, land use and zoning. To represent this, we added an extra ontology to our city's knowledge graph. This ontology represents zoning, land use, and program. The ontology regulatory relationships between these classes include particular zones that allow particular land uses, some zoning types allowing mixed use, and particular zones exclude certain program types. As such, this representation of regulatory policy is also added to the city's knowledge graph. This step-by-step overview illustrated how the main concepts of knowledge graph and semantic web technology come together to inform urban planning and urban policy. The main message is that the city's knowledge graph creates a shared knowledge base of city data and urban knowledge, resulting in a shared environment where data, policy, and analysis evaluation are directly linked to each other and can be compared to each other and can be expanded and improved incrementally. In summary, a city's knowledge graph can inform governance instruments, such as standards, principles, and targets, and help to evaluate them. Thank you very much.